This is the game called Compound Football. This game goes along with Lesson 15 in your text, where your students will be learning how to make compounds using polyatomic ions. Initially in this game, you'll just use the monoatomic ions to play, and then as your students understand the game more fully, you can add more of the polyatomic ions. To play this game, you'll need a large playing area such as a field or a gym floor to play. What we have set up here in our model is our playing area, and on each end of the playing area you'll have two safe zones or end zones like you might have on a football field. In the center of the field you'll need to mark a scrimmage line, and this can be can be a hose laid on the ground, or you can use a sack of flour and sprinkle out a white line, or just if you're playing on a dirt surface, just scratch a line across the center of the playing area. If you're playing on a gym floor, just use the center line of the basketball court as your scrimmage line. Now you'll divide your students into two teams, and it doesn't matter size or ability on the teams because as play progresses, the team members will constantly be trading back and forth from team to team. One team you'll designate as the cation team, and the other team you'll designate as the anion team. You'll need to select a team captain for each team, and what we generally suggest is that you choose the oldest team member to be the captain. And so that because team members will be traded back and forth as play progresses, whoever's the oldest on the team at that time will become the current team captain. Now, beforehand, something that you'll need to prepare are the playbooks for each team. The cation team will have the cation playbook, and this is just an examples here. The playbook, like for a football team, are the list of plays that they can use for each down or each round of play. And we've listed here just some of the monoatomic ions: hydrogen, lithium, sodium, potassium, calcium, and magnesium. Notice we have some +1 cations and then some +2 cations. And so the members of the cation team, the team captain, will have this playbook that he can use with his or her team. Likewise, the anion team will also have their playbook, and we've got fluoride, chloride, bromide, iodide, oxide, sulfide as examples here. Note again, these are just monoatomic ions, and we've got some -1s and then some -2 anions. So here with the anion team, they'll have their playbook. Also, the team captain will hold that playbook on their team. So to begin play, each team will form a huddle back near their safe zone or their end zone, and the team captain will choose, with help of his teammates if necessary, an appropriate play or ion to use for the current play or for the current down. Once that play has been chosen, each team will then line up on the scrimmage line like linemen would do for a football team. So we'll get the cations here on their side, and team captain will come here, kind of like the quarterback, and then we've got the other team. They'll also line up, each knowing what their play is. Okay, so let's get them all lined up. And what we like to do is ask, they need to be within a certain distance from the scrimmage line and not get to where they're lining up far away from the line. And you'll see why here in a moment, why that's necessary. So you've got them all lined up on the scrimmage line, and then your job will be to give a cadence, kind of like what the quarterback does to begin a play. And so you can say something like hut, hut, go. And then on the go signal there, the team captains from each team will shout their play. And so, for example, let's pretend that the cations have chosen the hydrogen cation. So this team captain here will say hydrogen cation, and over here, let's pretend the anions that they chose the fluoride anion. So he'll say fluoride, and then depending upon whether to form the compound between hydrogen and fluoride, depending upon that ratio there of those two components of the anions, determines what happens next on the play. Now in the case of hydrogen and fluoride, to make the compound, it would be H1. It would take one hydrogen cation for every one fluoride anion. So it's a 1-to-1 ratio. When it's an even ratio, 1-to-1 or 2-to-2, okay, the cation team has charge of the play, or what they do is they will chase the anion team back to their safe zone. So in this case, it's a 1-to-1 ratio. So all the anion team members need to run back into their end zone, to their safe area. At the same time, the cation team members are chasing them. So everyone will move in this direction to the safe zone. If a cation team member tags an anion team member before they make it to their safe zone, that anion team member then becomes a cation and goes to the cation team side. Okay, let's look at another example. Let's suppose back here in the huddle, okay, that the cations, they chose potassium. Okay, so they'll come to the line all knowing that their play is potassium. Now they don't reveal this at any time to the anion team. And let's say this time the anions choose chloride. Okay, so they'll come to the scrimmage line. So we've got a combination of potassium and chloride there. Again, you'll give the cadence, so you'll say hut hut go. The cation captain, he'll yell out potassium. The anion team captain will yell out chloride. Again, we've got a compound that would be a 1 part cation to 1 part anion. It would be the K1 Cl minus 1, so it's a 1-to-1 ratio. And again, because it's an even ratio, 1-to-1, the cation team's in charge. They will chase the anions now back again to their safe zone. Alright, let's look at an example where we don't have a 1-to-1 or an even ratio of parts that make up the compound. Let's suppose that the cations chose sodium, which is Na+1, and the anions chose oxide. So our compound then would be sodium oxide. Now recall that oxide is a -2 charge, so to make the compound we would have Na2O1. So we've got a 2-part to 1-part compound here, which is not an even ratio. Okay, so the teams would all come to the scrimmage line. Got a little offsides there. They come to the scrimmage line. This team captain would yell out, it was sodium, right? Sodium, and this team captain would yell out oxide, and then the teams would then realize they don't have a 1-to-1 ratio or an even ratio of 1-to-1, and in that case the anion team is in charge, and they will chase the cations back to their safe zone. So all these cation team members would run back to their safe zone, being chased by these anion team members. If any anion team member tags a cation team member, they go and become a member of the anion team for the next round. So the key here is, if you have the compound, if it's an even ratio, whether it takes one cation to one anion, the cation team members chase. If it's anything but an even ratio, if it's a 2-to-1 or 1-to-2, or as if when you develop a more complex playbook where you have some +3s and some -3 cations or anions on your list, then any of those ratios where it's not an even ratio, the anion team members do the chasing. Now, initially, your students may be rather confused for the first few plays, but then as they understand how the ratios work, and then when they run, when they chase, then play becomes really active, very exciting. You can help your students by, if you know beforehand which plays are going to be used by each team member. So what you would do is before you give your cadence, you'd have each captain come over and they'll whisper to you one at a time what play they intend to call, and then you'll know ahead of time if it's going to be an even 1-to-1 or 2-to-2 ratio, or not an even ratio where you've got something like a 2-to-1 or a 3-to-1 ratio. Then you can point in the direction. You'll know which team will be in charge, and then you can point, and that way as your students are learning the game, they can look to you and know which way to run. And then eventually you can quit doing the pointing and have your students mentally write that compound in their head and then know which way to run. So like we said, this is a very active, fun game. We think your students will very much enjoy it, especially as the playbooks get longer and longer with the ions, polyatomic ions that they've been learning. And we think you'll just have a very fun, good time with this game.